Hey everyone, welcome back. In the last video, we left it at, we had some of the basic constructs of SD-WAN created, and we were, in fact, able to manually switch between the internet tunnel and the MPLS tunnel based on performance of the SLA that we had defined to the loopback living on firewall number 4. So that's great for the data center connectivity from the branch site, but now we need to kind of focus in on the internet performance as well. So what I mean by that is, so if we go back literally where we left off, we had done a demonstration on the SD-WAN rule where we came in, under the zone, where we adjusted the cost manually and demonstrated how we can kind of influence the steering of the traffic from one tunnel versus the other. So I'm going to lower this MPLS tunnel cost back to 10, and that will switch it over to the MPLS, which it did. And again, that's referencing, or that's leveraging the loopback performance SLA that we had built here that was measuring the performance across both links back to the data center. So ultimately, we need to kind of measure the performance on the internet as well. So there's a few things we're going to need to do. I'm just bringing up some notes here. Okay, so to simulate that, what we'll do is on our internet switch, we're going to define a loopback called 8888. All right, so I'm going to hop on the internet box, and if we show IP interface brief, we can see that we just have essentially the next hop or the gateway for all the internet connections. We're going to just do nothing more than create loopback 0. We'll give it an address of 8888. It'll just /32 is fine, and we'll no shut that. Okay, so we have that address, and that's just going to be the destination of a performance SLA that we define on our branches to measure the quality of the internet at any given time. So what we should be able to do is we're going to hone our focus on firewall 2, just because there's no sense in doing the same exact thing twice. So I should be able to ping, let's just see what we got. So this is going to kind of set us up for the other changes that we need to incorporate. So right now we can't ping 8888, okay? So what we need to kind of look at is kind of our routing table, right? So we knew that we had some static routes defined. The first one is nothing more than the management, so we can disregard that. We had created a simple static route for any and all MPLS destinations to go out the MPLS, any and all internet, or I should say to reach the 100.network for internet, go out port 2. However, we don't have a default route, so we're never going to be able to ping 8888 if we don't have a default route. Now, when we introduced the concept of the SD-WAN zones, okay, we had created 2 zones, one for internet and one for the SD-WAN VPN tunnels. So now what we need to do is we need to create a default route that essentially sends the traffic out to the internet. So let's come back to static routes. We'll create new, and essentially what we're going to do is 100.1.1.1, right, or 254, 100.1.1.254. Okay, so that's going to basically point to SD-WAN internet is where I want to point this, okay? So see, it didn't even need the gateway. So when you do this, so the idea around this, so actually we're going to change this too. So we're going to actually add, we're going to do some forward thinking here. So we're going to add the SD-WAN VPN as a destination as well. And this will make more sense in a little while. I'll kind of come full circle and explain why we're doing this, okay? But this is the power of Fortinet's SD-WAN solution is it allows us to create these zones with multiple exit points in them, and that's how we can steer the traffic easily and efficiently, okay? So all we're doing is sending a default route out those two zones, and we're gonna build SD-WAN rules around that to determine when and why we're sending traffic over one versus the other. So if we come back to SD-WAN rules, okay, we have to do a couple things. There's a couple building blocks that we have to put in place. So we have the static route now, okay, but we never built a firewall policy on the branch side to allow traffic directly to the internet, okay? So we're going to go ahead and create that policy as well. So we're going to create new, and we'll call it DIA out, so direct internet access out. So anything coming from our LAN, all right, anything going out to the internet, and source we'll just do all, destination we'll do all, service all. In this case, we want to have NAT turned on, so we want to translate our address because this is going straight out to the internet. We'll just use the outgoing interface. There's no need for a pool in this particular case. We'll log everything. Obviously, in a production environment, you're going to want to set your security profile so that you can secure the environment. In this case, I'm not going to bother, and I'm going to enable this rule. So now we have a DIA out rule that says anything from port 3 to the internet, we're going to allow it and NAT it, okay? So now we come back to our SD-WAN rules. We're going to create a similar rule so that allows or denies the traffic. Remember, the policies are what enforces what's allowed and what's not allowed. The SD-WAN rules are what steers the traffic one way versus the other. Let's go ahead and just change this name to be something a little bit more friendly. We'll call it SD-WAN out, just because it just makes more sense. And then we're going to create another rule, and we're going to call it DIA out. So destination all, and we'll stick with our lowest cost. So we should be able to use this. Oh, I forgot one thing, sorry. So that 8888, right? We had built, let's just see first of all, can we ping yet? No, we still can't ping. Okay, so we're going to create a new performance SLA to point to 8888. So we can call it, you know, Google. Should be fine. So 8888. So for the members, we're going to basically specify the tunnels. All right. We'll give it the same target we used last time. I think we said 150, 50, and we can say 2% packet loss. We can change these as necessary. So let's OK that. Now, it's not working yet. Obviously, we need to get those pings to work for that to come up. But at least now we can build our rule and reference the performance SLA. So we're going to create the rule for DIA out. Okay, so source will say all. All right, destination will say all. We'll stick with the theme of the lowest cost. So for the interface preference, we're going to say, essentially, it's going to, at the end of the day, should be able to use any one of the 3 transports. So we're going to put all of them in there, okay? For the target, we're going to reference the performance SLA we just defined, and we're going to OK that. So based on cost, our direct internet access out SD-WAN rule is going to favor port 2, which is exactly what we want. For anything destined for the data center, it's going to favor the MPLS because we agreed that we would use MPLS, take advantage of the quality of service and the guarantee that it is a more dependable link. So we're looking good for our SD-WAN rules. Like I said, the only performance SLAs that we're going to have in play for the moment are Google and the loopback. Okay, so we're able to, actually this one should get port, I thought I put that in there. That should get port 2 as well. Okay, good. Right, so you can see here, so this is good. So now we're actually able to ping 8888 over port 2. And it's measuring the performance that we want it to do, right? So this is good. This is a good sign. Now, the reason this is failing over the tunnels is because it's most likely being dropped by the firewall in the data center, okay? So let's hop over to the data center firewall. And in our firewall policies here, we only have the SD-WAN out and the SD-WAN in. So what we need to kind of consider is, depending on how the traffic's routing based on the performance of the links, if the branch has an issue with the internet, so let's go back to the topology. So if this link on branch 2 starts to degrade, right, starts to suffer from whatever, we want to fail the traffic over automatically to go over the MPLS, which is the tunnel, back to the data center, and then right back out the internet, okay? However, right now it's trying to ping the internet over that link, and when it gets to this firewall, the firewall doesn't have a policy to allow that traffic to happen. So that's what we need to accommodate now. So we're going to create a new policy, and we'll call it branch backhaul, okay? Incoming interface is going to be either one of the tunnels. The outgoing interface is going to be the internet, all right? The source will just say all, and in our case it's the subnets of the branches. Destination will say all. Service, we will say all as well. Now, remember, this is internet-bound traffic, so we're going to want to do NAT in this particular case. So we're going to leave network address translation turned on. We'll do our logging. And again, same story as the branch. We'd want to enforce our security policies, or profiles, excuse me, to protect ourselves. And we'll make sure this is enabled, and we'll say OK. So immediately after I refresh the page, and if we right click on any one of the columns, you can go to hit count as well and apply that. So now we can see that we've taken 9 hits since I just built this rule, okay? So what that means is, if I refresh the page on branch 2 for performance SLAs, we can see now that that rule is in place, our performance SLA is able to communicate with Google through the data center. So we'll give this a minute, and they should all come down to 0% packet loss. So we're getting there almost. Another minute, another 20 seconds. All right, let's refresh one more time. Okay, perfect. So now what we see is, now we have our performance SLAs defined for data center, normal data center traffic, so anything to the 10 network. And then we have the performance SLA we just created for 8888. So now we should be able to effectively start to steer traffic depending on the quality of our links in play, right? So we can see based on our rules, so we're most likely gonna wrap this up here, and then I'll just dedicate one more video to this series where we can really just test, introduce packet loss, introduce delay, whatever we want to do, and we'll go through all the different failure scenarios and make sure this is doing what we expect it to do. So we can see though, just to kind of summarize, based on our zones, so we know that the internet has the lowest cost of 0. The raw internet port 2 has a cost of 0. So that means our direct internet access should always go out port 2 as long as the link is performing optimally. The SD-WAN has the 10 and 11, so that means that the MPLS is going to be favored over the internet. And if we go to our rules, we should see the check mark next to those corresponding interfaces based on those costs. So this Performance SLA, by the way, this needs to change. This needs to be Google. Okay. Okay, that's what we want. So let's just refresh this page one more time. Okay, that's what we want to see. So SD-WAN out, anything for 10 dot is going to favor the MPLS tunnel. The internet tunnel is there as a backup in the event that the MPLS starts to have issues. So again, next video we'll start to introduce some of those scenarios where we see the failover happen live. The DIA out is always going to favor the direct internet port, which is port 2, and then we'll introduce some issues to that link, and we'll make sure that the backhaul fails over automatically as well. We can see that the Performance SLAs should drop down to 0 here in a second. Okay, good. So right now everything's healthy, running clean the way we would expect it. So we'll pause here. We're going to come right back on the next video, and we'll actually do all the failure situations, verify that the SD-WAN's working the way we want, and most likely wrap up the series on that video. So I appreciate you guys tuning in. Thank you, and I will see you on the next one.